All right, Algebra 2, we are going to go ahead and start the graphing portion of Unit 7. So in this first part 1, we're going to look at graphing exponential functions. So the general function is y equals a times b to the x minus h power and then plus k. All the transformations that we've learned from last semester, all those apply again to this unit on graphing. All right, so we have two different kinds of exponential graphs that we're going to be graphing. One is exponential growth and one is exponential decay. And from the word problems that we just came off of from Unit 7.6, you kind of understand as far as what the equation looks like, what's growth and what's decay. All right, so it's all based off that b value. So y equals b to the x power. So the b value, so the number that's carrying the exponent, if that number is bigger than 0, then we're going to get its exponential growth. And so its shape is going to look something like this. It has this curve. Okay, it runs to the left forever, and then it goes up to the right. And it starts going up at an angle, so you can see that kind of like a smooth curve. So it's not going to go straight vertical, and it's not going to go straight horizontal. But on the horizontal, it's getting closer and closer to the x-axis without touching it. All right, and then if the b value is between 0 and 1, so fraction or decimal between 0 and 1, it's got to be positive. Then it's exponential decay, and then its shape kind of does a reflection over the y-axis. So it's going to run to the right forever, and then it's going up on the left side. All right, and then there's what's called the horizontal asymptote. And so that horizontal asymptote is where the graph gets closer and closer to without touching. So in the parent function, which these are, these general shapes, it's going to be the x-axis. That's where it starts. But in general, the horizontal asymptote, or where the graph gets closer and closer to, is going to change, and it's all based off the k value. All right, and so we get the horizontal asymptote by this equation, y equals k. And then we can see where k is in the problem. So it's that number that's at the end of the equation. All right, so let's go ahead and graph each of these, and then we can answer these questions at the bottom, the domain, the range, and the horizontal asymptote. So when we graph the parent function, again, we want to use an xy table just like all the other times. And we can always use -1, 0, and 1. Okay, every single time. So we can do that for every single one. This is how we start every time, every graph. Okay, for our table. So now we're going to take each of these x values, -1, 0, and 1, plug it in for x, and raise the base to that power. So 2 to the -1 is a half, 2 to the 0 is 1, and 2 to the first is 2. And one thing that you can recognize, if you use this -1, 0, and 1 in the parent function, these two numbers right here will always be reciprocals of each other. All right, and then this graph, if we plot it, okay, so -1, positive a half, 0, 1, and then 1, 2. And then we make sure that we understand what the shape looks like. This is exponential growth because that 2 is bigger than 1. So if we connect these, it'll look something like that. All right, and then we can get our domain and range. So the domain, if you look at what vertical asymptotes, or what vertical lines, sorry, intersect our graph, so we always start on the far left. That's where -infinity is. And we can see that that vertical line and our graph will intersect at some point. And so it's going to start at -infinity. And then as we slide that vertical line from left to right, every vertical line is going to intersect that graph, even over here at +infinity. And that's because our graph, the right arrow is going off at an angle. It's not going vertical, but it's going out at an angle, so it's going to intersect, really high way up there somewhere. So it's going to be negative infinity to positive infinity. Now our range, okay, we start from the bottom this time and look at what horizontal lines will intersect our graph. Well, we can see that this graph is never going to intersect our horizontal line that we drew at the bottom. So it's not going to intersect until we start to raise this horizontal line up, and it'll hit as soon as we pass 0. So it's not even going to hit on the x-axis because the graph doesn't touch the x-axis. So as soon as we pass 0, it'll hit. So we're going to start it off at 0 with a parentheses, not a bracket, and then it's going to go on forever. So even up here at positive infinity where we're sitting, those two will intersect each other at some point. So we can see right there, that's where it's going to intersect. Okay, and so we can say positive infinity. And then the horizontal asymptote, we can see from our graph, is going to be on the x-axis, so we say y equals 0. Okay, so that's the horizontal line that the graph gets close to without touching. All right, so let's look at the next one. Y equals 1/3 to the x. So 1/3, that's between 0 and 1, so this is decay. So our shape is going to flip over the y-axis. So when we plug -1 in for x, 1/3 to the -1, that means we have to do the reciprocal, so that's going to be 3. 1/3 to the 0 is 1, and 1/3 to the 1 is 1/3. Okay, again, we can see that these two are reciprocals of each other. So then we go ahead and plot our points. So -1, and then up 3, 0, 1, then 1, and then 1/3. It's down here. And then we connect them. So there's our graph. Our domain, again, we start from the far left, and we can see that the far left line that we would draw a vertical line would intersect our graph at some point. So we start at negative infinity. And as we slide that vertical line across, it's going to continue to hit forever, even on positive infinity. All right, and then our range, we start at the bottom again. Always start at the bottom for range. This is where negative infinity is. And it's not going to hit, so we have to continue to go up with it until we see when does it hit. And so this horizontal line will intersect our graph as soon as we pass 0. All right, so just like the other one, it's going to be 0 to infinity. And then we can see that the horizontal line that the graph gets closer to is going to be the x-axis. So we say y equals 0. All right, and then this third one, y equals e to the x. So you have an e button on your calculator. So remember, e is like 2.718. So we raise that e to the -1 power. So take your calculator, find your e button, and then raise it to the -1. Should be 0.3678, and so we can round it to just 0.4. Then e to the 0 power is going to be 1, because anything to the 0 is 1. And then e to the first, plug that in, that's 2.718. All right, and so we could go ahead and just round that to 2.7. All right, so then if we plot these 3 points, -1 and then 0.4, 0, 1, and then 1 up to 2.7, it's almost 3. So it's almost like the first one. It's still exponential growth, and that's because e is bigger than 1. All right, our domain going left to right is going to be negative infinity to positive infinity. Our range going from bottom to top is going to be 0 to positive infinity. And then our horizontal asymptote is going to be y equals 0, because that's the imaginary horizontal line that the graph gets close to without touching. All right, so let's go ahead and graph now with transformations. So what we want to do, again, our parent function, we strip down or strip away all the numbers except for the base and the exponent. So our parent function is going to be y equals 2 to the x. All right, so again, we have our negative 1, 0, and 1, just like before. We plug our numbers in. 2 to the negative 1 is a half. 2 to the 0 is 1. And 2 to the first is 2. Our transformations, the x minus 1, that's going to shift our graph left and right. And it does the opposite of what it shows. And so it's going to move to the right 1 unit. So right 1. And then the minus 3 moves the graph up and down, and it does what it shows. So minus means it's going to go down 3. And we can go ahead and affect these values from our parent function also. So we're going to do x plus 1, because it's going to do the opposite of what it shows in the equation. And then we're going to subtract 3 from all the y's. All right, so let's put our new values down. So negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And then let's plug in our y values. A half minus 3. So it's negative 2.5. 1 minus 3 is negative 2. And 2 minus 3 is negative 1. So let's go ahead and plot those points. 0, negative 2.5. Let's go down a little. 1, negative 2. 2, negative 1. Now our horizontal asymptote is all based off the k value, so that's the very last number, that's the up and down shifting. And so this went down 3 units, so our horizontal asymptote is now y equals negative 3. So let's go ahead and put that y equals negative 3 line in there. So this is like a boundary line that the graph's going to get close to, but not ever touch or cross. So now when I connect my graph, my dots, okay, so this is a shape, it's a growth, so we can see it's the same shape as before. It just got shifted to the right 1 and down 3. All right, our domain looks like negative infinity to positive infinity. And then our range, as we go from bottom to top, it's going to hit as soon as we pass that horizontal asymptote at negative 3. So we're going to start it at negative 3 and go up to positive infinity. So one thing that's nice, when we do domain and range, everything is parentheses. You'll never have brackets on any of these. All right, number 2. So again, let's go ahead and make our XY table. Negative 1, 0, and 1. Our parent function, y equals 1/2 to the x power. So when we plug our negative 1, 0, and 1 in, 1/2 to the negative 1, that's 2. 1/2 to the 0 is 1. 1/2 to the 1 is 1/2. All right, our transformation, it's like left 2. We have an x-axis reflection. And up 4. All right, so then our table, we're going to subtract 2 from all the x's, because you got to do the opposite of whatever number is next to the exponent. On the y's, we're going to multiply each y value by the negative 1 that's in front, and then we're going to add 4 to that answer. All right, so let's go ahead and find our new x and y values. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. Plugging 2 and 1.5 in for y. Negative 2 plus 4 is 2. Negative 1 plus 4 is 3. And negative 1/2 plus 4 is 3.5. So we can go ahead and plot those points. Negative 3 up 2. Negative 2 up 3. And negative 1 up 3.5. All right, our horizontal asymptote, so our horizontal line that the graph's going to get close to is the k value, so it's going to be y equals 4. So let's go ahead and put that in there, y equals 4. All right, so our graph can't touch that. So then when we connect our points, it's going to run to the right, but it's pointing down now because of the x-axis reflection. Okay, our domain is going to be negative infinity to positive infinity. Our range going from bottom to top, it's going to first hit at negative infinity this time because it's pointing down. And then it's going to go all the way up to the horizontal asymptote, so it won't cross past that. So we're going to say up to 4. All right, number 3. Okay, let's get our XY table. Negative 1, 0, and 1. Parent function, y equals 4 to the x. Plugging our x values in, we're going to get 1/4, 1, and 4. Our transformations looks like right 3. Vertical shrink by 1/2, and then up 2. All right, so how we affect our xy values, we're going to add 3 to all the x's. Add 3. And then on the y's, we're going to multiply each y value by 1/2 first. Then we're going to add 2. All right, so remember, everything that's up next to the exponent on the x affects your x's. And then everything else is going to affect the y's. So the number in front of the base, the 4, is going to affect the y, and then the k value, that adding and subtracting, that also at the end affects y. All right, so 1/4 times 1/2 is 1/8, and then 1/8 plus 2 is 2 and an 8. Let's see, y. So plugging 1 in, 1/2 times 1 is 1/2, plus 2 is 2.5. And plugging 4 in, 1/2 times 4 is 2, plus 2 is 4. Let's get our x values. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. So let's plot those points. 2, and then 2 and an 8. Just above 2. 3, 2.5, it's just a little bit higher. And then 4, 4. Our asymptote is the k value, so it looks like y equals 2. Y equals 2, so let's go ahead and plot that. Y equals 2. So this again is our boundary line that the graph doesn't cross. And let's go ahead and connect our dots with our graph. All right, our domain going left to right looks like negative infinity to positive infinity. And the range going from bottom to top, it's not going to hit at negative infinity, but it will as soon as we pass the horizontal asymptote. So we're going to go from 2 all the way up to positive infinity. All right, so now let's do some with E. So it all works exactly the same as before. Again, we use our negative 1, 0, and 1. Our parent function, y equals e to the x. Plugging a negative 1 in for x, just like from the very first page of these notes, e to the negative 1, we can go and round it to 0.4. E to the 0 is 1, and e to the first, we can go and round it to just 2.7. All right, our transformations, looks like it's going to be a horizontal shrink by half, because remember, everything that's next to the x does the opposite, and so instead of multiplying by 2, we would divide by 2. And if you divide by 2, that means the numbers are going to be cut in half and get smaller. So we say vertical shrink. So vertical shrink by a half. So that's the opposite of multiplying by 2. We multiply by a half. And then we can also go down 3. All right, so our x values, we're going to multiply by a half. Our y values, we're going to subtract 3. So let's see, a half times negative 1, that's negative a half. A half times 0 is 0. And a half times 1 is 1 half. All right, 0.4 minus 3, put it in the calculator. It's going to be negative 2.6. 1 minus 3 is negative 2. And then 2.7 minus 3, that's negative 0.3. All right, so let's go ahead and plot these points. So negative a half, that's left a half, and then down 2.6. 0, negative 2. And then positive a half, and then we want to go down just a little bit at negative 0.3. All right, so we can see this is exponential growth because the base, e, is bigger than 1. So we know the shape. Our asymptote is going to be y equals negative 3. So let's put our horizontal line in. So this is our boundary line. And we connect them. Our domain, negative infinity to positive infinity. Our range, it's like negative 3, positive infinity. And let's do one more graph. Okay, so just like before, negative 1, 0, and 1. Our parent function, e to the x. Our y values, just like before. Our transformation, looks like it's going to be a y-axis reflection, up 4. All the x values, we can multiply by negative 1 or divide by negative 1. That's the same thing. Multiplying by negative 1 or doing the opposite, which would be divide by negative 1, is going to result in the same answer. So just say negative x. And then up 4, so we're going to add 4. All right, so negative 1 goes in for x. That's going to be positive 1, 0, and then negative 1. And then 0.4 plus 4 is 4.4. 1 plus 4 is 5. 2.7 plus 4 is 6.7. Plotting those points, 1, comma 4.4, 0, 5, negative 1, and then up 6.7, right? so this point right here is not right. All right, so let's do this again. 1, 4.5, 4, 0, 5 should be there, and then I did it as 2, 5. So 0, 5, and then negative 1, 6.7, that's up there. Our asymptote, y equals 4. Put our dotted line in there, y equals 4. Let's draw a graph. Okay, run it next to your asymptote. All right, so our domain, negative infinity to positive infinity, and then our range looks like 4 to infinity. All right, now we're going to go ahead and write equations. So create an equation of a function whose parent function is basically y equals 2 to the x, has been vertically stretched by 3, shifted right 5, down 3. All right, so let's go ahead and write this. Okay, so stretched by 3, it means we're going to multiply by 3. We're going right 5, and so that's going to affect the x next to the x, and so that's going in the positive direction, but we have to do the opposite when we write the equation, or take it out of the equation. So we're going to go minus 5, that means we're going right 5. Down 3, we're going to go minus 3. All right, 7, create an equation of a function whose parent function is f of x equals e to the x. Okay, start it like that. Then reflected over the y-axis, that means we have to multiply by the negative on the x. Vertical shrink by a fourth, so we're going to multiply by 1/4. And then up 4, we'll go plus 4. All right, so remember, vertical stretches, shrinks, up, down, that's all vertical stuff. Those numbers are either going to be at the very beginning of the function or at the very end. The horizontal stuff, or y-axis reflection, or left and right stuff, that's going to affect the exponent on the x. All right, 8. What would the range be given this equation, the range? So in these kind of problems, the best thing to do is kind of just do a quick sketch of the graph. You really only need, like this part right here, that 3, that's just going to stretch it and, shrink it, but it's not going to affect the range. It's just going to make it more narrower of a graph, that's all. All right, so we know our parent function, this is growth, so we know the parent function y equals 2 to the x would look something like that. So then if it got shifted left 1, and then down 4, where would it be? Well, if you kind of think of where the asymptote is, it's going to be here at negative 4. So if we take our whole graph, move it left 1 and down 4, our new graph will basically be something like this. So now if you're looking for the range, go from bottom to top. Well, it looks like it's going to be negative 4 to infinity. So sometimes it helps just do a quick sketch of the graph to see what it's going to look like for the domain or the range. All right, so what would the range be given this equation? All right, so again, this is an exponential growth. This is where it starts. So what's happening? Well, we have the 4 is not going to do a whole lot. It just stretches and shrinks and makes it narrower or wider. It's that negative that we're looking for, and this plus 5. So what happens? It flips over the x-axis, so it flips over. Okay, so it's going to be pointing down, and then it goes up 5. So that means there's a horizontal asymptote at positive 5. Okay, horizontal asymptote at positive 5. The whole graph shifted, it flipped over and then went down, or went up 5. So if you think of it, it's flipped over and then goes back up 5, it would look something like that. So then our range, going from bottom to top, would first hit at negative infinity and then go up to 5. So you can see that k value is used in the range. It's either at the end or it's at the beginning. All right, that's it.